So, hello everyone. I think we should start with today's session, and I hope I am audible to all of you. So, I'll just share my content. So, I hope the presentation is visible to all of you. And in this today's session, we'll first discuss the MCQ answers to the week 2 questions, and then we'll talk about some conventional and non-conventional energy resources, and we'll discuss a little bit about the GHGs. So last week in this problem solving session, I gave you 3 questions as home assignments. So last week we talked about how we calculate log reduction values and the pathogen concentrations while our lecture on QMRA. So I believe most of you would have completed this assignment. So in this question, you were supposed to calculate the log reduction value for a particular hypothetical microbe for the primary, secondary, and tertiary treatment stages. So I had already provided you with the formula, and I expect you to please write down your answers in the chat box. So you can, if not, you can solve the question right now as well. So you had to calculate the log reduction values for 3 treatment unit processes, right? So post your answers in the chat box. So I am waiting for the answers. You were supposed to calculate the log reduction values for 3 unit operations. Okay, I see some people are joining still now. So I'll just repeat again, if any one of you has completed the previous week's assignment, and please take care that such kind of questions may appear in your exams. So you have to be attentive during the sessions. So you had to calculate the log reduction values for the treatment processes, and I already provided you with the formula. Okay, so I believe nobody has solved the question, or either you are not able to solve it or you could not understand, whatever be the reason. So I'll just discuss the answers now, right? So this was the treatment line which you had been provided with. So there are 3 treatment processes: primary, secondary, and tertiary. You have the raw wastewater going from this end, and finally you get the treated effluent. Okay. Now there is a hypothetical microbe, let's say A. So there are different concentrations of these microbes in the all the effluents. And I already told you in the previous session that this CFU per ml, it is just a unit for addressing the pathogens. Okay. So that is colony forming units per ml. So you don't have to get confused about it. You just have to calculate the log reduction values. So I already provided you with this formula that log reduction is log base 10 Cb minus log base 10 Ca, where Cb is the concentration of pathogen before the treatment and Ca is the concentration of pathogen after treatment. So this was a very straightforward numerical. All of you could have easily solved this. You just had to put in the values and calculate the log reduction values, right? So suppose if we start with the primary treatment process. So this is a primary treatment process, right? So what we have to do, we have to just put these Cb and Ca values in the formula. So you have log 10 Cb will be concentration before this treatment. So that is 5.46 into 10 to the power 7. So we have this 5.46 into 10 to the power 7, right? Because for the primary treatment process, our Cb is this. Then we have Ca, that is a concentration of pathogen after treatment. So after treatment means after primary treatment. So that is 5.46 into 10 to the power 5. So the only thing which you had to do in this was identify the value of CB and CA, which is very simple as I have already provided you with this treatment line. Okay. So when you solve this, you get log 10 5.46. So you're just implying simple mathematical operations here, and finally you get the answer as 2. Okay, so this is simply log 10 a into b is log 10 a plus log 10 b, and then you are just solving it out and you get 2 log 10 log base 10 of 10, and then you finally get 2. Okay, so this is quite simple. Again, when we talk about the secondary treatment process, okay, so for secondary, your concentration of pathogen before the treatment will be this, right? And after treatment will be 5.46 into 10 to the power 2. Because this CV and CA, they are with respect to a particular treatment process. So you just have to identify what is the concentration before and after. So again, when you apply it, you get a log reduction value of 3. Similarly, for tertiary, the concentration before treatment is 5.46 into 10 to the power 2, and after treatment is only 5.46. Okay. So you get a log reduction value of 2. So for each unit process, you can calculate log reduction values, and for primary, for this question it will be 2, for secondary it will be 3, and for tertiary it will be 2. Okay, so I hope you all have understood this calculation. So for this question, the answer will be 232. So the first one, A option. Okay, let me just check if anybody of you has answer in the chat box. Okay, so I see nobody has answered, so nobody is performing the home assignments. That is to be performed by the instructor only, right? Good. So now coming towards the 7th question, right? Calculate the concentration of waterborne microbe X in the primary treated, secondary treated, and tertiary treated effluent, provided the concentration of X in raw wastewater is 38,000 cells per liter. So again, you have a simple treatment line. Okay. In this question, you already know the log reduction values. In the previous questions, you knew these concentrations. After all the treatment process, you had to calculate the LRVs. In this question, you have the LRVs and you have to calculate the pathogen concentrations. Right? So for this also, I have already provided you with the equation. Just give me a second. There is some kind of disturbance. Yeah, all right. So we have an answer B by a student. Okay. So you're providing, I suppose you're providing this B answer for the 7th question, right? Okay, so let us check if B is correct or not. So for this, you had to calculate the pathogen concentration after primary treatment. You can see the primary treated, secondary treated, and tertiary treated. Okay. So this will be the primary treated, this will be the secondary treated, and this will be the tertiary treated. Okay. So you have to calculate. You had to calculate the concentration at points A, B, and C. So this is the calculation. This formula was already provided to you during the lecture. Okay. So for calculating concentration after a particular treatment process A, what you have to do is you have to divide the concentration before A, that is pre-A, by 10 to the power log reduction value achieved during A. Okay. So when we talk about primary treated, we already know that raw wastewater concentration is 38,000. Okay. So this will be 38,000 by 10 to the power 1, because the log reduction value for primary is 1. So you get the answer is 3800 cells per liter. Similarly, when you do for secondary, the pre-secondary concentration will be this. Okay, it will be 3800. Then 10 to the power 2.68. When you go for tertiary, the pre-tertiary concentration will be this, and you just have to, that will be 7.939, and the log reduction value for tertiary is 3.2. So you have to just put in the values and you directly get the answer. So for this seventh question, the answer will be, in the primary treated there will be 3800 cells per liter, in secondary treated 7.9, in tertiary 0.005. Okay. So this is 3800, 7.9 and 005, right? So the answer is B. This one. This is the correct answer. Okay. I suppose the student provided the answer as B, so that is correct. Whoever has provided, okay, good. Good job. At least you are trying to solve the questions. And this means that you are attentive during the sessions. Now moving on towards the last question. There were three questions which I provided you with. Okay, so in this question, what you had to do is, you have to calculate the probability of illness per person per day, right? So you had to calculate the daily probability of illness for exposure to E. coli and SARS-CoV-2, and you were already provided with the daily dosage for both the pathogens, and you were also provided with the models that have to be used for both the pathogens. Okay, so daily dose has been provided as 0.52 and 0.47. Then for E. coli, you had to use the beta poison model, and for SARS-CoV-2, the exponential model. Okay. And this was already given that probability of illness and infection is 1. So if there is an infection, there will be an illness. Okay. It's 100% chance that the illness will be there. Fine. So I already provided you with this beta poison model equations and the values for the coefficients, and similarly for the exponential model. So let us see if anybody of you has you have tried to solve this question. Please post it in the chat box if you have solved this question. So you can even if you are okay, so there is an answer C or D. Okay, so either way, either you are not attentive during the session or you are not trying to understand the concept, whatever is your issue, I encourage you to please come up and respond to that, okay, and let me know what is your issue, because this is supposed to be an interactive session, right? So if you are not interacting, then the session is futile. Okay, these questions are supposed to be solved by you, not by the instructor. So let us see what is the answer. One student has answered C or D. Okay. Now, why there is a confusion between C or D, let us try to solve that. So now what is provided to us in the question is, we have E. coli dose as 0.52 and we know that beta poison model is to be used. For SARS-CoV-2, these are the values provided. So first let's talk about E. coli. Okay, so this is a model which is given to us. Now the values of D, N50 and alpha is required, right? So alpha is given 0.373, N50 is given 214.94, and D is provided to you as 0.52. So you just have to put in the values, okay, and you'll get the answer is 0.048. Similarly, when we talk about exponential model, K is provided, D is known because exponential is to be used for SARS-CoV-2, so D is 0.47. Okay, so we have 0.47 and 410, and we get the value is 0.0011. Okay, so the daily probability of illness for E. coli is 0.0048 and for SARS is 0.0011. So which means that the correct answer is D. Okay, so whoever has answered C or D, yeah, so the correct answer is D. Still there is response from only one student, so it's good. Now for today's session, we are supposed to discuss about conventional and non-conventional energy resources and a little bit discussion about the GHGs. So you all must be familiar with both of these concepts. So energy, we all know, it is defined as the capacity to do work, and it is measured in joules. So 1 joule is when you're applying force of 1 Newton over a distance of 1 meter. That is a simple basic definition of energy, right? And what is power? Power is the rate at which the energy is transferred. So these all diagrams are self-explanatory in nature. So this is kinetic energy here. Then when the rock is lying, it has potential energy. Now this is again here kinetic energy and potential energy. So these all are very simple basic concepts, that energy is simply defined as capacity to do work, and 1 joule will be when you are applying force of 1 Newton over a distance of 1 meter, right? Now when we talk about energy, there are different units and scales across which these different energy units are used, right? We all know about joule, kilojoule, megajoule, maybe gigajoule. After that we have terajoule, petajoule, exajoule and zettajoule, right? Now when we use these units with respect to what activities, and what are the scales, okay, or what are the conversion scales that is being depicted in this diagram. Suppose if you are burning a small candle, you will be using the unit of kilojoule. But if we are talking about power plant and electricity production, we'll talk about petajoule, right? Because it is not possible that you say 15.50 So that's why it's not possible, and it's not explanatory, not easy to understand as well. So we use petajoules, right? So if you are talking about a city, the electricity, any energy use of a particular city, then we talk about exajoule. And zettajoule is used if you're talking about the world primary energy usage. In that case, you have exajoule, and beyond that, we go to zettajoules. Okay, so this is just to give you an idea how we actually go and use different kinds of units with respect to different processes. Now, when we talk about the global energy system, so the global energy system, it includes all the components which are related to production, conversion, and use of energy. Okay, so when I talk about conventional and non-conventional energy resources, so there is a basic definition for that, right? But I want to introduce you to some different aspect of that topic. So first we talked about energy. Now we'll talk about the global energy system, and then gradually we'll go towards the conventional and non-conventional energy resources. Okay. So the global energy system, it talks about everything relating to production, conversion and use of energy. And all this content about global energy, it is prepared from this GA report. It's a very nice report. I encourage you to go and go through that report. It's easily available online. Fine. So continuing, what is the basic purpose of the entire energy system? It is just fulfillment of the human demands, okay, which are now rising uh, day per day. So when we talk about this global energy system, we have different components. There is primary energy, secondary energy, end use applications, and the energy services. Okay. So these are the four different components of the global energy system. What is primary energy? Primary energy is the energy which is existing as it is in the nature. Okay, we'll try to understand these definitions with examples as well. So that is the primary energy. For example, coal. So it is as it is in the nature. So it is primary energy. But you cannot use it directly. Okay, so you have to harness it, and then you have to convert it into a suitable form, which will be secondary energy, or it will be the energy carrier, such as you are having electricity. So initially you had coal, now you have electricity. That will serve as energy carrier. So now after this energy carrier, you have to take that up to some to fulfill some end use applications, like to provide some light, to provide heat. So that is your end use applications. And what will be your energy service? It will be your thermal comfort or illumination, or if we talk about petrol, it's mobility, right? So these are the different components of the global energy system, right? Primary energy, secondary energy, then end user application, and finally the energy services. So why all these things are required? These things are required to fulfill the energy services that are required by the humans. Okay. So, and the key mediator between these things is how do we move from primary energy to secondary and then to the end use? That is through the energy conversion technologies. So this is an illustrative example of the energy sector and the energy end user services. So when we talk about the primary energy, for example, in the beginning here, we have the primary energy. So primary energy, as I told you, it is the energy which is as it is in the nature and you cannot use it directly. Okay. So you cannot use coal directly or solar radiation directly. You have to harness it and then you have to convert it maybe into electricity. Okay. So that will be the secondary energy. So in the primary energy, you have natural gas, coal, solar irradiation, or even oil. Then you convert it into your usable forms. So usable forms is a secondary energy. Then from secondary energy, you have the final energy. Okay. So final energy is which is available to the consumers. So through the distribution networks, these go to the consumers. Then you have the end use technologies. For example, for electricity, you are using it in a computer. So what will this end use will do? That will help us to serve an energy, provide us an energy service, which is information processing. Okay. So similarly, if you have natural gas, so natural gas is the primary energy. Secondary energy will be gas. Then you convert, use it in a furnace. That will be the end use technology. And final, the service which it is giving is cooking. Okay, so this is how the cycle goes from primary energy up to the energy services when we talk about a total global energy system. Okay, and ultimate goal is satisfaction of the human needs. Okay, now when we talk about how we move to primary to secondary, we have the conversion technologies. Okay, there are conversion technologies like power plants. So these power plants, they help us to move from a primary energy source, that is coal, to a secondary energy, that is electricity. Then through electricity, we go to these computer systems through the electricity grid. So that will be your distribution technology. And then finally, we are using it for our information processing, which is the final service. Okay. So this is the main components of the energy system and how do we move from one component to the other component. Now this represents diagram. It just shows you what is the global energy flow through the main stages of transformation, that is primary, secondary, end use, and then the service. Okay. So for example, primary, we have 496 exajoules of energy. Fine. So till it goes to useful form of energy, it remains only 169. So we know that 100% energy can never go. Okay, there are some losses during each stage. So this energy which is lost, so this is around 496. Fine. So you can see a large amount is getting exhausted and only small amount is getting used. So for example, like here I described about your going to coal to electricity. Similarly, here we have coal and we are finally going to light. So through electricity, they are earlier we had for computer and now they are going for light bulb, and the final energy service is illumination. Now, when we talk about the global energy system, and so we will see the world primary energy usage. So primary energy is again which cannot be used directly. We have to convert it. Okay. So these are the all the primary energies which have been represented in this figure. So we can see that during the 1850s, major portion was biomass. Okay, but as we moved towards 2008, there was industrial revolution, and then more and more with increasing demands, we see that we are having nuclear energy as well. So now this is gas, some portion is hydropower, and there is nuclear, and major portion is again coming from oil and coal. So this shows how the increasing demands, they have increased the usage of the primary energy resources. So you can see that there is a the exponential growth of global energy use at 2% per year. So which is a huge amount. At 2% per year, the usage is increasing. So again, when we talk about the global energy use, so this represents here that first we have the primary as per the primary energy, then as per the final energy, then as per the useful energy. So you can see that major sections is again by oil and coal. Okay, so this here represents the different countries or different regions as per the GA report, and this figure here represents the um, these regions. Okay, so what is covered in OECD 90, what are covered in this ref, what is in Asia, this is Middle East and Africa, and this is Latin America, right? So this is just to give you an idea what are the main primary energy resources which are being used all over the world. So you can see major section is covered by coal and oil. Okay, so still we have to make a lot of efforts. So this is from 2012. Okay, efforts have been made and still more efforts are required to we have to shorten this section where everywhere you can see coal and oil are used. So this usage has to be reduced and we have to go towards the renewable forms. Now if you see from the viewpoint of final energy, then also we can see that oil products and coal, they are the major section. Okay, so these statistics are just to show you how the energy usage is varying in the world and why we need to move towards the renewable energy forms, or what we call as a non-conventional energy resources. So now coming towards the energy resources. So resources are anything which is naturally occurring, maybe solid, liquid or gas, and it is in the earth's crust or on the earth's crust. And one point to be taken care of is that the economic extraction is potentially feasible. Okay, now when we talk about, when you see this diagram here, so this is called as a McKelvey box. Okay, now this diagram, it uh, provides you with the classification of resources. So this was developed by the US Bureau of Mines and USGS, right? So in this diagram we can see that there are two main things. One is the economic feasibility and other is the geological assurance. So how sure you are that that is a particular reserve for a natural resource. Okay, so we can see as per the economics, there are three sections, three subcategories: economic, sub-economic, and which is not economic at all. And as per the geological assurance, there are identified reserves and undiscovered reserves. So identified reserves include the reserves which have a known location, they have known quality and known grade. So all the characteristics about that particular reserve is known. Undiscovered means there is a potential that there may be such a reserve, but they are not yet discovered. So it is just postulated based upon the existing theories or existing materials. It is speculated that there may be a resource, but it is not yet discovered. So similarly for undiscovered, based upon the probability, that how probable it is that a particular reserve is there, you have hypothetical and speculative. So these are self-explanatory in nature, right? But when we talk about identified, we have again two categories, which is measured, indicated, and inferred. Okay, so this is depending upon the surety of that particular reserve. Okay, then there are certain unconventional and low grade occurrences. So there, here you have mostly the non-conventional paths. So coming towards the conventional and non-conventional resources. So conventional is obviously that resources which are once exhausted and they cannot replenish themselves within a specific period of time. So now the rate of consumption for this is much greater than the rate of formation. That is why the worldwide problem of this resource scarcity is happening. Okay, and it mainly includes coal, gas, and oil. When we talk about non-conventional, so these are the resources which can be replenished by a natural process. In the non-conventional, there is solar energy, wind energy, geothermal, bioenergy, and hydroenergy. Now we usually say that bioenergy is non-conventional, okay? But if you are harvesting the biomass at a rate which is greater than the rate through which it can be replenished. Okay, so if the harvesting rate is more than the rate at which it can be replenished, so do you think that bioenergy can be considered renewable? So then it will be unsustainable in nature. Okay, so even if for certain renewable resources, we have to take care of such points. So now when we talk about the renewable energy, so India's renewable energy is the percentage share of renewable energy in India is gradually increasing. So you can see that initially in 2014-15 it was around 5.56% and now it has increased up to 11%. So that is a big achievement for India. And if we talk about the individual renewable energy components, then we can see till 2007 till 2017. So these are not the renewable energy, but all the energy resources. So you can see till 2017, the major one was coal, but the bioenergy and energy from waste is somewhat increasing, right? And the major portion which is contributed in the renewable energy is by the hydropower. So you can see that major portion is through hydropower. Then we have wind and then we have bioenergy or solar. So we can say that most contribution to the renewable energy sector in India is given by the hydropower sector. And the contributions are, through the other processes is still increasing. So when we talk about the world energy, so these are just some facts. So energy consumption is growing on an average rate 2% per year, which is very high, and still most of this is consumed through the fossil fuels. Energy growth is not only associated, it is mostly associated with population growth and economic growth, both things, and it is a major problem basically in the developing countries. Okay, and the uninterrupted reliance on fossil fuels. So there are four main challenges to the sustainability. So the world is relying on fossil fuels and they are not giving it a second thought. And this is again posing four different challenges, which is it is increasing the GHGs, decreasing energy security, causing air pollution, and again lack of universal access to energy services. So you can see that there is not everybody is not having access to the energy services. 3 billion people don't have access to basic service and they have to cook with solid fuels. So these facts are just to get you acquainted with the energy scenario in the world. And this is again from the 2012 GA report. So when we talk about GHGs here, so it is a very common topic, right? And where it is now come to the limelight. So GHG, everybody knows what is the greenhouse effect. So when the sun, some of the solar radiations, when it falls on the earth, some is absorbed by the earth's surface, which keeps it warm. Some is reflected by the earth. Then some is in of the infrared, it passes through the atmosphere and it is absorbed and re-emitted towards the earth by the GHGs present in the atmosphere. Okay. Now the normal amount of these GHGs is very crucial. You see, it helps the earth to keep about 33 degrees Celsius warmer. So if the normal amount of GHGs would not have been there, then the temperature would be around freezing conditions would be there on Earth's surface and life would cease to exist. Okay. But the problem is that the GHG concentration is not normal now and it is increased to very high levels. So which is creating the problem of global warming. So this greenhouse effect, it is quite old. It was first proposed by Joseph Fourier in 1824. So this is a very common concept. Okay, now very much in the research domains. So you should have a slight idea about this facts as well. So this was first proposed in 1824. It was discovered in 1860 and first investigated quantitatively by Arrhenius in 1896. Right? So when we talk about greenhouse effect, there are this diagram represents the main GHGs. So we can say there are six main categories. First is the carbon dioxide, then we have methane, nitrous oxide, hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. So these are the six main categories when we talk about GHGs. So for carbon dioxide, the main parts you have it coming through transportation, fossil fuel combustion, coal and crude oil, right? Again for methane, mostly it is coming from agriculture and landfills. Nitrous oxide mostly comes from cars and manufacturing systems. Then hydrofluorocarbons and perfluorocarbons, they're mostly coming from semiconductor manufacturing and aluminum production. And sulfur hexafluoride is emitted during electrical transmission. So these are the six main GHGs when we talk about the global warming. And the ability of a particular GHG to cause global warming, it is defined by the global warming potential. Okay, so for the global warming potential, CO2 is considered as a reference, and global warming potential or GWP, it is defined as the heat which will be absorbed by the particular GHG in the atmosphere. So as with reference to the heat that would be absorbed by the same amount of CO2. Okay, so CO2 is a reference. So global warming potential for CO2 would be 1. For methane, it is 21. For nitrous oxide, 310. And then you have similarly for different hydrofluorocarbons, perfluorocarbons, and sulfur hexafluoride. So you can see these are the global warming potentials of the GHGs. So when you say that there is maximum amount of, or among these GHGs, suppose CO2 is present in the atmosphere in maximum amount, okay, and sulfur hexafluoride is only 10%. Let's just take an example, right? So, but you cannot say that CO2 is causing most of the global warming because its potential is only 1. But if you consider SF6 with respect to CO2, you see that its potential is very high, around 23,900. So even a small amount of this will cause a large amount impact on global warming, right? So this is just about the greenhouse gases and how you estimate their global warming potential. So when we talk about greenhouse gas emissions, what is the global scenario? So this is the scenario which is presented in IPCC 2014 report. So when if we see with respect to the GHGs, you see major is through CO2 and major industries are fossil fuel and industrial process. Then we have carbon dioxide, some part of methane, nitrous oxide and the F gases is 2%. If we talk about the economic sector, so major is coming through electricity and heat production. Then we have agriculture, forestry and other land use, that is AFOLU. Then we have transportation, industry. So research and further development or improvement is required in these sectors because they are contributing maximum to the greenhouse gas emissions, right? So such kind of reports or such kind of analysis, they help you to see the loopholes in the present technology and they help you to guide towards the improvement scenarios in sectors. So when we talk about the Indian scenario, so this is again um, from the Global Carbon Project, and we can see the CO2 emissions in India by fuel type. So major emissions is through coal, then you have oil, natural gas and other. So that is why we have to go towards the unconventional resources of energy. So if you go towards this, you'll not only save the resources but will also help us to reduce this GHGs. Now this is the from a source, it's a very nice platform, GHG platform India. So you can get all the data regarding GHG emissions through this platform, which is openly available on the web. So you can see that how through 2005 and then till 2015, how the contribution of different sectors to the GHG emissions has changed. So initially, and how the overall GHG has also increased. So in 2005, it was around 15 into 10 to the power 8. But now in 2015, so this is still 5 to 6 years back, so it has increased to 25 into 10 to the power 8. So which is quite a lot, right? So we can see that again the major contribution is in the through the energy sector, and there is some contribution through agriculture, and industrial products and waste is still contributing less to the overall GHG emission. So major uh, corrections or major rectifications are to be required in the energy sector so that these GHG emissions can be reduced. So this I have taken from the this GHG platform India, right? So there are four major sections when we talk about the global or national GHG emissions, right? Main is the energy, then we have AFOLU, where that is agriculture, forestry, and land use. So we have a combined category for all the three things. Then we have waste and industrial process and product use. Okay, so there are four main sections when we talk about GHG emissions. So you can see this is in the 2015 through the GHG platform India. When we talk about energy, so you can see that 1862 million tons CO2 emission is being emitted. When we talk about the regions, so it also gives you an idea about the regions. You can see mostly the contribution is by through this Maharashtra. Then we have Gujarat and Uttar Pradesh with almost an equivalent emissions. Now, in the energy sector, from where the major emissions are coming? So, majorly it is coming from the public electricity generation. You see, 51% of the part is coming through electricity generation process. So, we have to go towards some renewable resources based electricity, right? Or maybe some hybrid kinds of things. Then 25% is through industries, 13% is through transport, and then 10% is through other different processes. So major you have through electricity generation. And what are the main gases that are being released? So majorly we have CO2, and that is again coming from publicity electricity generation 53%. Then we have methane, and some part is nitrous oxide. Then if we talk about the agriculture, forestry and other land use. So we can see that majorly, so this is mostly coming from Uttar Pradesh. Obviously the agricultural, this domain would come from here. And you see that top remover is Kerala, right? And major, this is coming from enteric fermentation. So due to enteric fermentation, the GHG emissions are released during that part. Methane is released, then nitrous oxide is released during this fermentation process. That is where it is coming, right? Then again during rice cultivation, lot of methane is released, so it is contributing 19%. Then through agricultural soils, you have methane coming out, so again 14%. And there is some amount of GHGs through manure management as well. So these processes, they are to be taken care of, particularly the like how you can reduce it through the during these processes, right? Now the main gases which are again, now here main gas will be methane, because during rice cultivation, during the from the agricultural soils, from manure management and from fermentation, methane is a major gas which is being emitted. So the main is methane, then you have some part of nitrous oxide and a very minute amount of CO2. Now similarly, when we talk about the waste sector, mostly it is coming from Uttar Pradesh, Tamil Nadu and Maharashtra. And mostly you see around 63% is coming from domestic wastewater. So during domestic wastewater treatment, you are treatment, discharge or everything, you're giving around 63% of GHGs. So in the next session, I'll also maybe try to incorporate how GHGs are emitted from the water sector, right? So I think that will be an interesting domain, because we all know how GHGs are emitted from the electricity sector or maybe from the agricultural sector and even from the industrial sectors. But through water sector, it is quite less discussed. So I'll try to incorporate in the next session. So you see that 63% GHGs are emitted from the domestic wastewater and 25% through the industrial wastewater, right? So there is around 88%, more than 80% GHGs which are coming from this wastewater sector. So we need to improve this wastewater treatment discharge. So this water sector needs to be improved a lot, because more than 80% is coming through this, and only 12% is coming through the municipal solid waste. And among the GHGs, major GHG is your methane, which is again given by the domestic wastewater. And 19% is only nitrous oxide, but again the major contributor is domestic wastewater. So this domestic wastewater treatment has to be treatment or transmission, this discharge, it has to be taken care of. Now when we talk about the industrial processes and product use, you see the major emissions are from Rajasthan, Gujarat and Andhra Pradesh, and mostly it is coming from the mineral industry. After mineral industry, some part is coming from chemical industry, but again the major gas is CO2 and methane is a very minor amount. Okay, so this was just to give you an idea what are the main GHGs that are being emitted in the Indian sector, in Indian scenario through different sectors, right? So coming to the question answer session, so I'll expect some of the students to please respond to these questions in the chat box, right? Which of the following is not an example of primary energy? So we have already discussed on primary energy. We have already discussed what is primary energy and how it is transformed to secondary. So which is not an example? Chemical energy, which is embodied in fossil fuels or biomass, or the kinetic energy of water drawn from a reservoir, electromagnetic energy of solar radiation, or specific energy of jet fuel. So what is not an example of primary energy? The energy which is stored in the fossil fuels, the kinetic energy which is there when the water is drawn from reservoir, solar radiation, electromagnetic energy, or the specific energy of a jet fuel. So I'll just check the chat box if some of you are responding to the questions. Okay, so one has answered A. No, A is not the correct answer. Which of the following is not an example of primary energy? Okay, so another answer D. Okay, so I see most of the students are responding. So you respond in the interactive sessions, but you forget to do the home assignments, right? Okay, so most of you are answering D. Okay, so D is the correct answer, right? Because all the other things are, all the three, these are energies which are stored in the nature as it is, right? So correct answer is D. Now primary energy is not used directly, but it is first converted and transformed into secondary energy. Which of the following is not an example of secondary energy? Electricity, coal, jet fuel, or heating oil? So which among these will not be an example of secondary energy? So let me see if you have the answers. Okay, so most of you have responded B. Okay, so one is responding D. Which of the following is not an example of secondary energy? Electricity, coal, jet fuel, or heating oil? So this is a very general question. If you are paying attention to the first part, you will obviously get the second answer, right? So let us see if we have. So it will not be D, the answer will be B, because coal is an example of primary energy. It is not an example of secondary energy. So the third question, which of the following is true with respect to secondary energy? Primary energy is harnessed and converted to produce secondary. Secondary serve as energy carrier for subsequent market transaction. Only first or both A and B. So which is false or which is true with respect to secondary energy? The primary is converted to secondary, or secondary serves as energy carriers for market transactions, right? So let us see what you have answered. Okay, I have got one answer. What about others? Okay, fine. So for third, the answer is D. It's correct. So both A and B. Now final energy is the delivered energy. that is transported and distributed to the point of retail for delivery to final users. So final energy is basically the energy which is available at the consumer end or the user end. So which of the following will not be an example of final energy? Luminosity of a light bulb, gasoline at the service station, electricity at socket, or fuel wood in the barn, right? So you try to read the question very carefully, give it a 2-minute thought, and then read the options also, right? Read it very carefully. So it is the energy which is transported and distributed to the retail point for delivery to the final users. So after this, it will be converted into the useful energy. Okay. So what is not an example of final energy? Luminosity of light bulb, gasoline at service station, electricity at socket, or fuel wood in the barn. Okay, we have two answers. One is D, one is A. Okay, so the correct answer for this is A. Because this luminosity of a light bulb, and you see this luminosity of light bulb and electricity at the socket, these are quite contrasting options, right? So any one of this would only be the answer. So luminosity of light bulb is the energy which is now it is now available to the user end. Okay, it is not the energy which is um, available for delivery. It is the one which is delivered, right? So the answer will be A. It is not an example of final energy. Now, final energy in end-use devices is converted into useful energy. So, final energy is now converted to useful energy such as a kinetic energy or heat. Okay. So, suppose if you are having a heater, right? So, that is an appliance. Energy in that is the final energy. But when you are using it, it is getting converted into a useful form of energy, that is heat. So, which is not an example of useful energy? Mechanical energy delivered by an industrial electric motor or heat of a household radiator, only B or both A and B. Okay, so we have three more questions. Which of these will not be an example of useful energy? So I see that nobody is responding to this now. Fine, so I'll just leave these questions to you for home assignments, and I hope that you will give me the answers. Then in the sixth question, you just note down these questions, or you can go through the lecture again, right? Select the odd one out with respect to energy services. So energy services is the one which is available at the user end, right? Moving vehicle or mobility, warm room or thermal comfort, light or illumination, or none of the above. So you have to select the odd one out with respect to these. Now this is a very short numerical, very simple, straightforward calculation. What work will be done if you pull out a 60 nail with an average force of 450 Newton? So you have to just apply the simple formula of work done, that is force into distance, and you have to come up with the answer, whether what is the answer in joules or kilojoules, right? So the force is given 450 newtons and you have a nail of 60 millimeter. Then this is the last question. You have to choose the odd one out with respect to global warming potential. So global warming potential of CO2 is 1, global warming of CO2 is 100. Then for methane it is 21, or for nitrous oxide it is 310. Okay. So these are the 4 questions which we'll discuss in the beginning of the next session. There is 5th, 6th, 7th and 8th. Okay. So thank you for joining today's session and see you next week. All right. So okay, I see we have some answers for question number 8, only 2 answers. So we'll discuss it in the next session, right? So you can leave the session now. Thank you.